So hello YouTube community. I just poured myself a glass of whiskey because I think I earned it after a day's work of trying to set up this presentation. We're going to look at the flat earth, and what we are going to do is use the facts as they exist within flat earth. So I'm not going to talk about NASA. That's irrelevant whether if the earth is flat. I'm not going to bother you with mathematics. Also won't do dirty tricks and show you no fake perspective. I won't bother you with science, only the flat earth facts. No religion, because most Bible text or that of the Toran or Quran are already in the flat earth facts. No GoPro camera discussions or no discussions, can I see 10 miles or 40 miles over a little bit curved earth? No, we stay with a flat earth. So this is also not a discussion about whether the earth is the center of the universe. For all I care, it could be a ball which is the center of the universe. The only thing I'm going to show is that if it's flat, then I'm going to use that as proof. And that's where we start with fact number one. Fact number one, the earth is flat. And this is what it looks like. The diameter is about 25,000 miles. And in March, red circle, the sun circles the pole at approximately 6,000 miles from the pole. It does that fact 4 at the height of approximately 3,000 miles. But I don't care if it is 2,000 or 4,000. It doesn't matter for what I'm going to prove to you. Fact 5 is that in June, in the summertime in the north, we all know that the days are the longest. And the path is described here as the yellow path. And in December, as you can see here, it's the orange path. That is when on the southern part of the hemisphere, or on the outside of the equator, the sun will make this curve in 24 hours. That are the facts so far until fact number 6. So I'm going to bring to the stage Norris. He lives in Ireland. That is fact 7, 2,500 miles from the pole, and he lives somewhere here. And my other friend Sam, South America, he lives in the tip of Argentina, which happens to coincide with where Norris is living. It's 2,500 miles from the edge. Fact number 8. And fact number 9, important, is that people in South America do not have better eyes than people in Europe, America or Canada. We're going to look through their eyes. So if you are in doubt of what I tell you, go outside and look for yourself, or ask somebody on the other side of the equator. And I do not say on the other side of the globe, because for the moment that doesn't exist. We only know a flat earth, and that was fact number 1. Everything I'm going to show you can be verified. Just go outside and look. All you need is a good pair of eyes and a clock. In the pictures we are going to show you, you will see the following things. The way you will perceive the sun. What night looks like with or without moon. And arrows. The arrows will show you the direction one of these two guys is looking. And how high they probably will perceive the sun. Now these two guys, they have something in common, and that is there is one day in the year that they have the longest day. For Sam, it is on December the 22nd when the sun rises around 5:30 in the morning and the sun will set around 10 o'clock in the evening. And for the people on the northern hemisphere, we all know that the longest day is around June 22 or 21, and that the sunrise is fact number 13 around 5:30, and the sun will set around 10 o'clock. Fact 14. We see objects disappear in the distance because of perspective. I have no problem with that, so we follow it. Fact 15. The time difference between Norris and Sam is 4 hours. That basically means that on the 22nd of December, when Sam is having his longest day, he's watching the sun at around 7 o'clock in the evening. It will look like this. Norris will be preparing to go to bed because it is 2300 hours at his location. And 2 hours later, for Sam, the sun is 1 hour before sunset. He will see it probably like this, and Norris will probably be asleep. Fact 17 is then what the perceived view of the sun is. You can check it, just go out on the south part of the equator and look at 22 December up, you will see this at that time, you will see that at this time. And in December, everybody in the north knows it's Christmas time and the sun goes down already very early, so Norris will have a good dark night. On the 22nd of June, the longest day for Norris, you will see here his perception of when the sun rises, how it gets to its highest point, and when it goes down, and again the arrows and the presentation of what he sees. Important to notice is the sun will not rise in the west, it will already rise somewhere, in the east, but it will rise somewhere in the northeast, and it will go down north-northeast. We come to fact 18. According to the flat earth, the sun goes down because of perspective. And because that, there is another fact, and that is the sun will be too far away, as we can only see a limited distance. So that's one of the other reasons they give why we see the sun disappear, and especially when it is a ball that is hovering above the earth. Everybody says you should be able to see it. Now it disappears at a certain distance because you can't look that far, or the sun rays can't reach you that far, and that's because of the air in between and the humidity and whatever. But from now on we will also make arrows that represent, let's say, the distances to the sun from the view of our two friends. Now, when can we now debunk the model? That is clear. If I have a person, one of those two, that is looking at the sun, and he sees this, and the other one is looking at a far larger distance and he sees that, then the model doesn't work. If this happens on a flat planet, then it doesn't work. The model is wrong because the whole perspective argument and the whole distance argument disappear. This cannot happen on a flat Earth. If it happens, then the Earth is not flat. Let's look at Norris. Norris lives in Ireland, as we said. We already saw what the sun does, but now we have the distances to the sun. And we can see when the distance increases, the perspective will make the sun go down. And if it's far enough away, you can't see the sun anymore. And then later the sun pops up. But we already see a little problem here, because at 10 o'clock we can still see the sun, the way you see it here. And at a smaller distance in the morning, it is still dark for Norris. But I don't mind. This could be, let's say, the morning humidity that takes care that the distances are not exactly correct. So So we saw what it looked like for Norris, the same view for our friend Sam, only for him the whole world is upside down in a sense, not on a globe, but for him the sun will pass in the north at 12 o'clock. That is what you see here. Only the problem is that all the eyewitness reports from people living in the south is that on 22 of December the sun rises at 5:30 and it does it in the southeast. And it disappears, the sun sets in the southwest. And here comes the biggest problem. This is not possible on the flat earth. So maybe this is all bullshit, but that means that all the eyewitness reports of these people, if you give them a call and ask, hey, where is the sun at the moment? If you do it then on 22 December and you ask, can you give me your compass bearing of the sun at 10 o'clock when it is disappearing behind the horizon? He will give you this bearing. And that is completely strange, of course, if we look at what he should see according to the flat earth. But it becomes weirder, so stay with me. Now, as we said, on December, the orbit for the sun and the moon is this orange line. And the sun goes round in 24 hours. So when Sam is looking at 12 o'clock noon, he is looking north and he sees the sun at its highest position. And the sun should be there at midnight. He will see the sun rise on the flat earth. You should see the sunrise here at 5:30. Then approximately an hour later he will see the sun at its altitude above the horizon. Then at 8 o'clock the sun starts to be very bright for him because it is the longest day. It's full summer for him. And then it will stay very bright, very white until, let's say, 5 o'clock in the afternoon. And then it slowly will go a little bit yellowish, but at 7 o'clock in the evening, there is no difference with Norris in the north on the 22nd of June. He will still see the sun very high up, very bright. And then at 9 o'clock in the evening, that's when the sun is here on the flat earth, he will start seeing this. Next step is the sunset. The sunset, according to the flat earth, would take place there at 10 o'clock. These are the directions on the flat earth. What is real is what people see. At 9 o'clock they will see this. At 10 o'clock they will see this. And if the flat earth is true, those are the positions where the sun is at that time. And they can see it with their eyes. So compare this with our friend Norris, who at the distance of approximately 5,000 miles notices that he no longer can see the sun, because from a perspective point of view the sun disappeared, or the distance became so big he can't see it anymore. We see a big problem. Apparently our friend in the south can look twice as far. Have a look at this. December 22, 9 o'clock in the evening, our friend Sam is seeing this. The sun is still going down, but it's an hour before it will really disappear behind the horizon. And our friend Norris, who is in bed, and we have seen that at that time for him it is already dark, looking in that direction, and he doesn't see the sun anymore. It is gone. It is night for him. Well, it gets even more weird. Let's look at Seattle. You can look it up, but at December 22, the Seattle sunset is 16:15. So somebody here in Seattle who will be looking at the sunset around, let's say after sunset, around 5 o'clock. He is looking in that direction, and it will be pitch dark for him. Where for our friend Sam, the sun is still high up. It is only 5 o'clock in the afternoon. The sun burns like hell, gives a lot of light, while at a much smaller distance the people in Seattle can't see it anymore. If we then wait 3 hours and we go to 9 o'clock in the evening, Sam is actually looking exactly in the same direction as the people in Seattle. Now, if there is any humidity or dark clouds or whatever that prevent the people from Seattle to see the sun, or when the perspective is such that they can't see the sun anymore, then it must be completely impossible for Sam to see anything. But it is only 9 o'clock in the evening, it is the longest day on the location where Sam lives, and he will see the sun like this. And this basically says that the map is, or the representation of flat Earth is completely wrong. We could also turn it around and say, well, if our friend Sam can see over this distance, what happens if I take the same distance and start in Ireland where our friend Norris lives? Then the circle you see here is what Norris would be able to see, apparently because Sam is able to see this distance and see a clear sun. Norris should be seeing that sun always if he has the same view capabilities as Sam, and which they have, which will work out like actually for Norris the sun would never set on a flat Earth, because the distance we have here is the same distance Sam can see at 1700, and that means Norris should see the sun all year long, every day of the year. So, what did we say? When is the model debunked? When this impossible thing happens, and we've just seen it happens. It is simply there, it happens every year again. Sam can see the sun here at the same time when it is pitch dark night for Norris. Actually, even Norris is much closer, and Norris is much closer to the sun than Sam is. So, I don't know what you want to make of this, but for me it is now clear that the flat Earth as a model cannot work, because what we see with our eyes, with our watch on our wrist, looking at the time, doesn't match up with the map. It is completely wrong. Thank you for watching, and sorry to disappoint you that there is no flat Earth.